Okay, so today we're doing rotations and reflections and translations. This is some material that's not within our it's a little bit tougher to kind of see these things, but I'm going to do the best I can to be able to visually show you how each of these different transformations take place. So a transformation is a change in a figure's position, size, or shape. Oops, yeah, no, that's right. Okay, so position, size, or shape. So the original figure, whenever I want to talk about the very first figure, it's called the pre-image, and then when we start moving it around, and then we have a resulting figure at the end of moving it around, that's what we're going to call the image. A reflection, just like your reflection in the mirror it's just you kind of reversed around, that's what a reflection is in geometry as well. So a reflection is a transformation. A reflection is a transformation in which the figure is the mirror image of the pre-image. So a way to think about that is that you're just flipping it around. So for example here, you can see that the first picture to the second picture is just a reflection of the first one, or it's a reflection of that pre-image to be able to make this image down here. And that's just, again, a reflection. And it's a reflection over that particular horizontal line that they have labeled, or they have there. This next one, I want you to try and figure out if you can't draw the image. So the B here is what I want you to replicate, but I want you to flip it, or I want you to reflect it over this line M, and then I want you to see if you can draw out where that should end up at. Okay, so I want you to try doing that. Next thing that we talk about is called a rotation. Given a point, a rotation is to turn a figure around a fixed point called the center of rotation. So you're going to essentially glue down one of the points, and then you're going to rotate it around that particular point in there. So if, for example, a triangle ABC, like this image ABC that you can see over here from that triangle, it was rotated. It was rotated clockwise. So a clock, how does a clock work? A clock works like goes around in that direction, so that would be clockwise. So it was rotated clockwise how many degrees about the origin? So I'm going to try and visually show this to you. So this is pretty much the exact same kind of a picture that was there just a second ago. I have the image down there. You're like, oh, I didn't even know that was there. Yeah, I know you didn't know it was there. I was supposed to surprise you. So if I have, this is the pre-image, and then I'm rotating this pre-image around the origin. Okay, so this is the center of rotation is around the origin. That means that I'm taking this, and it's going to be continually like equidistant away from this origin, and I'm going to rotate it around the origin. So one way I could do that is I could rotate it, like if I rotate it 90 degrees this way, it would essentially look like that. And then if I go another 90 degrees, then it would look like this. And if I go an additional 90 degrees, it would look like this. And then if I go a full 360 degrees, or another 90 degrees, then I'd be back to the image and the pre-image being the exact same shape. So the way that they have the picture is they have the picture like this. So how did we get there? How many degrees did we rotate it? Well, if I'm going in the clockwise direction, then rotating it, this would be 90 degrees. Rotated another 90 degrees, now we're at 180 degrees. Actually, it'd be more like right there. And then rotate it another 90 degrees, and now we are at 270 degrees. So if I'm going in the clockwise direction, that would be 270 degrees. What if I was going in the opposite direction? What if this is the pre-image, this is the image here, and I didn't go clockwise, but instead I went counterclockwise? Well, in order for that to happen, I would have started here, and then to go counterclockwise, it would have gone like this. How many degrees did I rotate it? I only rotated it 90 degrees when I went in the counterclockwise direction. If you look, like this piece right here is the exact same size as this piece is over here. This piece is this piece, and this piece is this piece over here, right? If I go back, Okay, each of those sides, they match up, and now I've just moved them over to there. So notice how the size hasn't really changed, it's just changed like with a position that it's in. So that's called a rotation. I can also rotate around a single point. So what if instead I wanted to rotate like around, let's go around this point actually. Rather than rotating around the origin, what if I wanted to rotate around this particular point? Well, I could do that by essentially keeping that point down. If I go in the clockwise direction, this would be 90 degrees that I've rotated it clockwise. And then if I go another 90 degrees, it would look like that. If I go another 90, it would look like this. And then if I go my last 90, or that's 360 degrees in total because I've done it 4 times, then I get back to the original image. So that's what a rotation is. Most of them we're going to do are around the origin, but you can also rotate around any point it is that you want to. A reflection, okay, so the difference between rotation and reflection, remember reflection is like you flip it over. If I took this and I instead flipped it over the y-axis, it would look something like that. If I wanted to, so notice this isn't the same thing as rotation. If I go back and I rotate it, okay, that's not quite the same thing. It's a reflection. Okay, if I wanted to take this and reflect it over the x-axis, then it would be flipped down over the x-axis like this. Okay, notice that it preserves this distance here as it is right there. Or you can think about like if I was to take this and fold it over, then this and this, I'm folding it over the x-axis, would be the exact same picture. Or if I reflected it over the y-axis, then right here when I flipped it over, right, if I folded that, it would be the exact same thing on both sides. So back to our notes, when ABC was rotated clockwise, we decided like clockwise going in this direction that it went a whole 270 degrees around the origin. Or if we went the other direction, if we went counterclockwise, so the opposite direction that a clock moves would be that direction is counterclockwise, then we decided that it went only 90 degrees when I went about that way, when essentially I moved it from here to there, that was counterclockwise. When I moved it from here to there, that was clockwise. The image, so the pre-image, we just leave it as ABC or whatever letters they are, and then the image, after we do our transformation, then the image a lot of times we'll put little primes on it to indicate that this is where it got moved to. So if you label this particular triangle, like this point A, which one correlates with that particular point A? Where did it get moved to? It got moved to right there. So that would be the A prime is how we would label that. And then the B, this point over here, it got moved. Okay, if I move it in the clockwise direction, then it would have gotten moved to right there, or if I went counterclockwise, and it would have gotten moved essentially that way, but it doesn't matter. But you can see that that would essentially be where B got moved to. So we would call that B prime, and this over here would be C prime. And as I mentioned before, like this distance between A and C, it just got moved to over here of A prime, C prime. But notice how that distance has remained the same on all of those sides as it was from the pre-image. So the last kind of a transformation we need to talk about is called a translation. Translation is actually very simple. It's just to slide all the points of a figure a fixed distance in the exact same direction. So for example, like on this picture, all I did was I just took this pentagon and I had it originally like over here, and all I did was just slide it somewhere over in here. Let's see where it was originally. Let me move it back to there it is. Okay, so that's where it got moved to. So they're telling us how we did this translation, that the figure was translated 6 units to the right and 5 up, and they want to know, well, where did D get moved to? If I move D in that direction that they were saying, go 6 units to the right, well, if I'm at -5 and I go 6 to the right, then that's going to move it to negative, or to +1 rather, because -5 plus 6 to the right would put us at +1. And then if I go 5 upward, well, it was at -3, so if I'm at -3 and I go upward of 5, then that's going to put me at +2. So that's where this point D got moved to. It got moved a total of 6 units to the right, and then it got moved a total of 5 units upward, and that moves it to the point 1, 2, which we're going to call that as D prime. An isometry. It sounds like a hard word. It's really not. An isometry is a transformation that preserves distance between the image, pre-image, and the image. So everything that we've talked about today thus far has been an isometry. When I did this translation, when I took this pentagon and I slid it over, all these sides, like those distances that they were from the pre-image, they're the exact same distances as they are on the image. If I look at when we did this rotation, right, we said that this distance from A to C is the exact same distance as it is to A prime, C prime. And same thing with all these other distances, those distances all got preserved. So thus, rotation is also a type of isometry. And then reflection. Reflection is also an isometry. Whatever this side looks like, and this side, it's the exact same lengths as it is over there. So reflection is also a type of isometry. So let's see here. Reflections, rotations, and translations are all isometric transformations. And another name for isometries is also called rigid transformations, which makes sense because they're not getting bigger, they're not getting smaller, they're just getting moved around. So that would be called a rigid transformation as well. So I want to show you this website that I have listed down here, and you're more than welcome to visit it on your own. So on this website, there's an applet, and you can play around with it with what a reflection is, a translation, and a rotation is. So I'm going to start with a reflection, and you can change the kind of shape that you want to. But if I take this triangle, and you can see that this red triangle, that is the pre-image, and then it got reflected over to where this image is over here. So if I want to take this pre-image, and let's say that I moved it backwards, notice that what's happening with the actual image, it's also going to be moving the same distance away from this line, whether I go forwards or backwards or whatever. If I want to move it up or down or whatever it is that I want to do, it's a mirror image on the other side. It's going to move in the same manner for a reflection. I can also change this line. See how the line is now changed from for the reflection? So now, rather than getting moved just left to right, it's kind of moving in this kind of a direction for a reflection. And you can play around with this, like you can like twist them, you can say, oh yeah, it's still reflected, all kinds of stuff. You can change this to a square if you want to, and you can kind of see, it's a little harder to tell in the square from this one, but like this point got reflected over to this point right there. Obviously it's easy when it's something like this, you can just see, oh yeah, it was reflected over easily, but when you start changing your line of reflection, it gets kind of interesting. If we go to a translation, so remember what translation is. Translation is just sliding them. So what this little arrow is showing us is how much are we going to slide them and in which direction. So maybe this arrow is telling us that I'm sliding it to the right 3 units and up 5. So if I take my image and my pre-image, you can see that from this point right here, like it went over like 3 units and then upwards 5 to right here. You can, again, it's just a slide. If I want to increase how far that I'm sliding it, notice how this is getting further away. So maybe I went over 4 and up 10 this time. So to get from this point to this point, I went to the right 4 and then upwards of 10. I can also like change, maybe a triangle might be kind of interesting. I can even change like on here the direction. So this one, maybe I'm going backwards 5. So I'm going to the left 5 and then upwards of 4. So to get from this point, I would go backwards of 5 and then upwards of 4, and then it would get translated over to here. Essentially, it's just like sliding. So if I took this one, I slid it 5 to the left and upwards of 4, this is the image that it would get to. Rotation. Rotation's pretty interesting. So rotation, if I take this and I rotate it, I can, maybe we'll start it at 0 degrees. Okay, so this is where it started at. And then if I want to rotate it around this particular point over here, notice how this triangle is going to go all the way around this point. So there it is at like the rotation of, let's go to 90 degrees. Okay, that's about 90-degree rotation. And then if I go another 90 degrees, or that's at 180 degrees, right about there-ish. And then if I go another 90 degrees, which should take me at 270 degrees. And then if I go another 90 degrees, it takes me back to the image, or that's a total of 360 degrees that I've rotated around.